Okay, lesson 522, how are properties related? So we're going to talk about properties of logs. So to kind of build on that last lesson, we're going to talk about how these properties are used and how they work. So there are three properties of logarithms, each corresponding, not surprisingly, right, to the property of exponents. When logs were first invented, right, tedious multi-digit multiplication steps were replaced by table lookups. And then obviously nowadays, calculators have kind of made those tables and things obsolete. So we're able to use calculators to obviously do this a lot. But let's look at these properties so we can simplify and kind of go through these. So first thing here, it says use a graphing technology. So a calculator basically to go through these and create this table. The big thing is going to be trying to do this. Hopefully, I can get my scientific calculator to work on here to show you guys. But let's see if we can do that. So let's just start with log base 2 of x. Let's see if I can get a log to come up here. Yeah. So yeah, sure, sweet. So luckily, there's log base 2, right? And the first one is at 1, right? So let's go log base 2 of 1. We see that's 0. So this first one right here is 0. Okay, and then log base. So let's go log base. I'm going to write these down. Log base 2 of 1 is 0. Okay, log base 2 of 2 is 1. So again, we got 1, 0, 2, 1. Log base 2 of 3. Let's do that one. Okay, so log base 2 of 3 is 1.58. 1.58. 1.58. Right, log base 2 of 4 is 2. So 4 is 2. Right, log base 2 of 5. So let's go 5. 5 log base 2 is 2.32. 2.32. 2.32, right? 6 log base 2 of 6. So let's go 6 log base 2 is 2.58. Right, and this is going to go on 7, 8. Log base 2 of 8 is going to finally be 3. Right, so let's go ahead and do log base 2 of 7, log base 2 of 8, which will finally get us to 3. But let's go ahead and go 7, log base 2, 2.8, let's say 81. And then obviously just for time, log base 2 of 8 is going to get us to 3. So we see those, right? And we kind of fill in this table here, right? Which I have kind of done right here, 2.81. Okay, and then it says, now use the table you created to create some patterns, right? So let's look at this. So A, we have log base 2 of 2 plus log base 2 of 3, right? So 2 of 2 we know is 1, and log base 2 of 3 is 1.58, which if we add those, we get 2.58, right? Which is log base 2 of 6. So what happened there? They took the 2 and the 3 and they multiplied them to get 6. Okay, well, let's look at B. Log base 2 of 3 plus log base 2 of 5. So again, 2 of 3 is 1.58. Log base 2 of 5 is 2.32. If we add those together, we're going to get 3.8 something, right? So based on what we said, if they multiply those two together, this should be log base 2 of 15. And it should be 3.8 something because we rounded. So let's just check that, right? So if we did log base 2 of 15, so there they got it's 3.90, right? So that's a rounding thing for us because we rounded. Um, Actually, sorry guys, that would be 3.90. Okay. Obviously longer decimals there. Sorry. Okay. But that way we can see those properties work. Okay. So now let's look at C. So the subtraction, a log base 2 of 12 minus log base 2 of 6. Okay, so we didn't do 12. We know log base 2 of 6 is 2.58. Let's figure out what log base 2 of 12 is. So let's pull up our calculator. All right, let's go log base 2 of 12. We get 3.58. So 3.58 minus 2.58, we get 1. Well, where do we get 1 at, right? At log base 2 of 2. So what'd they do there? They took 12 and 6 and divided them. 12 divided by 6 is 2. So let's look at D. Let's see if we get the same thing here. Okay, so we got log base 2 of 15 minus log base 2 of 3, right? So if we divide those, we should get log base 2 of 5. Okay, so did we do 2 of 50? Oh, yeah, 15 was 3.90 and 3 was 1.58. And that should get us 2.32, right? Which is what we get. So we can see there that they divide. So let's summarize these. Let's summarize these log rules, right? So let's summarize these. So if we had log base b of x plus log base b of y, it's the same as saying log base b of x times y. Or if we're subtracting log base b of x minus log base b of y, we're going to get log base b of x divided by y. Okay, so there's two rules, right? And what do they go with? Like corresponding, right? If we think about exponent rules, when we have two exponents, same base, different exponents, and we're multiplying, we add the exponents. Well, now when we're adding logs, we multiply, right? Same thing if you had if you were subtracting, right? If you were exponential and you're subtracting, it's division, right? So very similar there. Okay. So what other patterns do we identify, right? So does this work with any base? Yes, it does. And so 54 basically lets you explore that, plug in another base and try these same problems and explore that for yourself. Okay. Now let's look at an exponent here. So if we look at this problem, they have x to the n, right? So if we just use an n of, let's just say 2, what's going to happen, right? And so when you start plugging these in your calculator, what you're going to see is all these numbers that we just did are actually going to double. So it's still going to be 0. It'll be 2, right? They're all just going to be double. This is going to go to 4. This is going to go to 6, right? They're all going to double. And so again, try another base and see if this works, right? So what happens on that rule is this: if you have log base b of x to the n, it's the same as taking that n and multiplying by it, right? And just moving it to the front and multiplying by it, right? So it's the same process, right? So, all right, so now let's look at 56 and the patterns we created to write two equivalent expressions, right? So let's look here. So we have log base 7 of x plus log base 7 of x. Well, what is that? Log base 7 of x squared. X times x is x squared. Or we could bring that to the front and write log base 7 of x. Either one. Okay, if you're looking at b, right, this would be natural log of a to the fourth. That's 4 a's multiplied together. Or 4 natural log of a. Okay, on c, this is just kind of going backwards. You could write log base That's 10, sorry, of m to the fifth. Or we could write log base m plus log base m, right? Like we could write this out 5 times, right, to get that same solution that we just got. Okay. Looking at D, this is log base b of n to the third, or again, we could write 3 log base b of n. Okay, so now 57, right? If we look at this problem, Mr. Cooper decides to hold a contest. He gives his team the following expression, right? How many ways can you write it? So after time's called, they say, hey, David's team wins, but Maddie's team says you didn't check to see if they were right. So who really wins, right? So let's go through this and see if we can figure out who wins here, just to kind of help understand what they did. So let's take the start, right? Log base 2 of 8 plus log base 2 of 8 plus log base 2 of 8, right? And that's 3 of those. So this is log base 2 of 8 cubed, okay? Or 3 log base 2 of 8. So there's one for Maddie's team, right? Log 3 log base 2 of 8, right? 8 cubed is actually 512, right? So that's 512. There's another one for Maddie's team. There's that log base 2 of 8 cubed that we already wrote for Maddie's team, right? If you look at this one right here, 1024 divided by 2 is actually 512, so that one works, right? And then that same deal, if you write them as subtraction, that's the same as that division problem, so that's the same. And then what is the log base 2 of 8? Well, 2 of 8 is 3, and 3 times 3 is 9. So 3 plus 3 plus 3 also gets you 9. So this works too. So Maddie's team got them all right. Okay, well, let's go through David's team. Well, we just said 9 works, right? But if you look at this one, right, we're actually we're dividing those. So 1024 divided by 512 is log base 2 of 2. So that's wrong. So this one actually doesn't work, right? So we're already tied, right? So 3 times log base 2 of 2 to the third. 2 to the third is 8. So that corresponds with this one right here, right? So that works, right? So if we bring the 3 to the front, 3 times 3 is 9. So this one actually works too, right? What about this one, right? This one actually works because 2 to the ninth is 512. So like we're still here, right? So this works too. Okay, what about this one? Okay, this one actually doesn't work. And this would be one I would tell you to test in your calculator, right? This also doesn't work because it's the log base 2 of 24, which instead of doing like 8 to the third, they actually multiplied these and got 24, and that's not an exponent. So just a bunch of different ways to write these depending on what you're trying to do, and that's where these properties come in. And so properties proved, right? Like you can prove these. I'm not going to take the time to do this, but just showing you these properties that I just wrote out up here, right? So these are these 3 properties that we already talked about, right? So let's go to 59 and let's just work this problem. So can you apply the properties of logs here, right? So you actually cannot, and I would love for you to take the time to actually put this in your calculator and then try to use a property. And what you will notice is that the bases are different. So the same rules apply in exponents. If the bases are not the same, then you cannot combine those, right? It's a different base, which changes the value. Okay. 60. Can you use the properties to rewrite these logs? Okay. Well, so let's look at 60A. So this is log base 10 of 5 plus log base 10 of 7. So 7 times 5 is 35. So we could definitely do that. Right on B, you're adding, and then, sorry guys, it kind of blurred this in part C there. So B is this. So 50 times, this would be natural log of 50 times 100, right? Which is 5,000 over, whoops, and then we're dividing. So over 25, right, which would actually go in 200. So this would be log base, or excuse me, natural log of 200. You could also do that if you wanted to go ahead and do it. C is hard to see over here, but it's the log of 17 to the third, which we could rewrite as 3 log of 17, right? D gets a lot of people because this is the natural log of 4 to the 27th times 4, which is 4 to the first. So this is the natural log of 4 to the 28th, or you could also bring that 28 to the front, right? Same with E. I would go ahead and say this is log base 2 of M plus log base 2 of N squared. Go ahead and bring that in, and then this would be log base 2 of M times N squared. Okay, and then it's hard to see F. Okay, but it's very similar to B in the sense of you're dividing and then multiplying. So very similar in that case. But I'll show you this one on F. So this would be natural log of A divided by B times C, but C could also go on top, right? So this would be natural log of A C over B. Okay, and then the last one here, 67 is show that the log of 4 of x is equal to 1/2 the log base 2 of x. Okay, so how do we do this, right? Well, first off, 1/2. So you could do this a bunch of ways, right? But 1/2 goes to the x, right? So log base 4 of x equals log base 2 of x to the 1/2, right? So let's put this in exponential to see it a little better. Um, um, Trying to think to help you guys truly understand this. Um, yeah, let's just write this in exponential form. So this would be 4 to this power, right? To this power equals x, right? So it'd be, log base 2 of x to the 1/2 equals x. Okay, but here's the deal. In order to cancel that, right? Like in our previous lesson, this needs to be 2 to some power, right? So log base 2 of x to the 1/2, right? So these cancel, but this 2 comes inside, right? Remember, it's an exponent, right? So 2 times 1/2 is actually 1. So this leaves you x equals x, right? So they are equivalent, and that's what we were trying to prove there. So this is lesson 522.